So there's three different ways that you can really charge up an object, and one of which we have, well, actually two, we've seen in class already. The first one is going to be by friction, and friction is going to be one of those things where we've already kind of talked about it. It's whenever you have one surface rubbing against another surface, and in this case, that rubbing actually takes off electrons from one surface and puts it onto another, and usually between one insulator and another insulator. Okay, hopefully you're familiar with the terms of insulator and conductor. Insulator means that the charges can't really move around a whole lot, and a conductor is something like your wires in your cords and in your walls and things like that, where charges can move really easily. So to kind of give you an idea of friction, we have a little um, simulation here. And in this simulation, we have a balloon and this wool sweater. So the balloon I can take over here and rub against the wool sweater, and notice what's happening. I'm stealing basically electrons from the atoms in the wool sweater. So now this balloon has become negatively charged. This is very similar to basically the same thing as when you rub a balloon through your hair or run a comb through your hair and pick up something with. But if you notice, the positive charges are staying where they are. Okay, in the nucleus of an atom, you really can't remove protons from there without changing the entire structure of the atom. But you can remove the outer electrons from the atom. So now I have this negatively charged balloon, which means it has an excess of negative charges, and this positively charged sweater, which basically means that it has a shortage of electrons. And if I let go of the balloon, you can see that it's just attracted to this wool sweater. And I'm sure you noticed this in class. Whenever I charged up a balloon, it becomes attracted to me. But when we think about it, I'm not really electrically neutral, or excuse me, electrically positive. I'm kind of like this wall sitting over here, where I have just as many electrons as what I do protons, so I am neutral. But if I take this balloon over here to the wall, what do you notice? You're actually pushing the electrons away from the balloon. And when you do that, you're letting the surface of the wall become positively charged. Okay, you're pushing these electrons away, and there's now a kind of a pocket of positive charge over here that is now attracting the balloon. I can put the balloon wherever I want. Okay, if you remember on this first day of class when we had a charged up balloon attracting something like wood, like the ruler or the big 2x4, then this is the situation that's going on. This is known as polarization. A polarization where you have one charged object pushing another object who's not charged and causing it to be polarized. And this is going to be important as we see in some of the other types of charging. So this is charging by friction, where you're physically taking electrons off of one thing and putting them on another. Both of these things would be considered insulators because charges don't really move at all. Okay. The next thing that we can do is called charging by conduction. And you remember conduction, we talked about this when we had thermodynamics, where conduction involves contact, right? You want to touch a duck, right? So if you are charging by contact, then you are physically touching that object. And then the other one being charging by induction, where you actually don't have a touching of one charged object to another. So let's see what conduction and induction actually look like. So in this case, we have an object here that has zero charge. All right, sorry about that. My videos weren't working. Okay, so for conduction, you can see that right here we have an object that has no charge in it whatsoever. And this is not necessarily a great picture of no charge because this is an object. It's made out of material. It should have both positive and negative in it, much like the wall did on the simulation. But what this is showing is that there's no excess charge. It is not charged up. It does not have an extra amount of electrons in it. All right, now if we take this rod, which does have some extra electrons in it, which is simulated by the blue spheres in here, and we take this and touch it to the object, then what you're going to see is electrons actually going over to the new object. Okay, let's go back to that. So this is what we mean by charging by conduction. There's physical contact between this charged object and this uncharged object, causing some electrons to move over. Now we know that electrons repel each other, so given the opportunity for some of these electrons to move over, they're going to, because they repel away from each other. So now what you have is two charged objects. Because they're in different sizes and different shapes, we probably can't say that they're equally charged objects, but we do know that they would have the exact same amount sign. So this would be negative and this is negative. Or if this was positive, then this would be positive. If this was a positive situation, then it would be slightly different. You'd have electrons going from another side over to fill the positive hole. So that is conduction. Okay, remember that you can pause and rewatch anytime you need. Okay, induction is a slightly different process. Remember that induction has nothing to do with actually touching the object from one charged object to another. So this is what induction looks like. So this is going to be a sphere who still has no excess amount of charge, but what I'm showing here is that it's got the same number of protons as what it does electrons, protons being the red spheres, electrons being the blue spheres. So it's not an excess amount of charge here. And what we're going to do is we're going to bring a charged object near it. So here's the charged object. We're going to bring it near it, but we're actually not going to touch it. Now in this particular situation, if you recall what happened with the wall when we brought the balloon close to it, is that we actually have a separation of charges. So if this is a negative charge, it's going to push all the electrons, or at least a lot of the electrons, over to the opposite side of this sphere because electrons repel each other. And electrons are the only things that really can move. So what we've simulated here is that we have an area of positive charge. Protons have not actually moved. Protons don't move when you're talking about an actual atom in a solid. But what we have here is an absence of electrons, which is causing this to be positively charged. All right. The next step is going to be we take in something called a grounding wire. So what we're doing is we're allowing these electrons that are sitting over here a pathway to get off of the charged sphere. So here the electrons are now allowed to leave, and if we now take away this charged object, what we have now is a sphere that is positively charged. Okay? It does not have the same amount of electrons as what it used to. So this is now a positively charged sphere, and it has been created by a negatively charged object. If you recall back in conduction, we have two objects that had the same sign of charge, but in induction we have two objects that have the opposite sign of charge. And notice how we never really touched this charged object to the uncharged sphere, but we still ended up with a charged object. So these are the three different ways that you can charge up an object. So just to go back, we can charge up an object using three different methods. We can do it by friction, which is electrons are physically rubbed off one insulator and put onto another. We can do it by conduction, where you're actually in contact with the object, or induction, when you're actually charging up without contact. And recall, this conduction causes both objects to have the same sign of charge, while induction has the opposite sign of charge. And I'm going to let you watch this right here, which is a little animated GIF. Let's see if it'll work. There we go. And this is going to run through what induction actually looks like. So we have the separation of charges because you brought something close by. You're allowing something to go to ground. This is the symbol for ground, so it's like the grounding wire, or you touching it. And then you take away this charged object, and you're left with a sphere that is now positively charged. So induction results in the opposite charge, conduction results in the same charge.